Unit 1, Lesson number 7, Solving Linear Systems Using Substitution. So here's another video on solving a linear system using substitution, but this particular example is going to give you a result that you're not sort of used to seeing compared to the other examples I gave you in a previous video. So here's the example. Where do the lines 2x minus y equals 4 and 4x plus y equals 9 intersect? So again, we have two linear equations. Let's label the first one on the left as number 1 and this one over here as number 2. And we're going to follow the usual steps to solving using substitution. So the first thing I'm going to do is isolate one of the variables in one of the equations. So it looks like, well, pick the equation with a variable that has a coefficient of 1. And it's going to be equation number 2 here because this y variable has a coefficient of 1. I don't like this one over here in this equation because it's negative y, so I'll stick to the positive y. So we're going to isolate y in equation number 2. Okay, and so if I do that, what do I have to do? Well, I should subtract 4x from both sides of the equation in equation number 2. So it's going to be y equals negative 4x on the right side plus 9. Okay, and I just rearranged 4x and 9 instead of writing the 9 first. Okay, so there's my y variable. I have isolated it, which means now I can go back to equation number 1, and in equation number 1 I can replace or substitute the y variable with this equation number 2. So for equation number 1, here we have 2x minus, so here's my y variable. I'm going to replace the y variable. And if you have a minus sign, it's always a good idea to put some brackets. Make sure you put brackets because you're going to have more than one term here when you're substituting. So when I put that brackets in there, I replace the y minus 4x plus 9. And then on the right side of my equal sign, you still have a 4 there, so write the equals 4. Okay, so you have a minus negative 4x plus 9. So you're going to distribute that exponent, distribute the minus sign, and you're going to expand that bracket. So here we're going to write 2x minus 4x is plus 4x, and the minus 9 is minus 9. So here we go, equals 4. Then we're going to collect like terms. So 2x plus 4x is 6x. Minus 9 equals 4. And then if I add 9 to both sides of my equation, I will have 6x equals 4 plus 9. And then I divide both equations by 6. Let's just simplify this first. So 6x equals 13. And then x equals 13 over 6. Now here we have a fraction, which is what I was trying to say. It's a little bit different. What happens if your solution is a fraction? Don't convert it to a decimal, especially if you're going to get a repeating decimal. It's not going to be it's not going to give you an accurate answer for your point of intersection. So leave your variable as a fraction. Ideally, put it in lowest terms. Okay. So our next step here is going to be to substitute x from 1 and put it into 2. Okay. So here's equation 2. Let's write it out. So equation 2, 2x, yeah, so 4x. Well, okay, it doesn't have to be equation, yes, let's say 4x plus y equals 9. Now you can use equation 1 as well. Any of the equations will give you the right answer, but I'm just going to use a different equation just for the sake of using a different equation. And so here my x is 13 over 6, so 4 times 13 over 6 plus y equals 9. Okay, and so 4 out of 6 can be reduced to 2/3. So 2 times 13 over 3. So I mean this is how it's working. So this becomes a 2, and that becomes a 3. Okay, so 2 times 13 over 3 plus y equals 9. And so if I try to simplify this thing here, 2 times 13, multiply those two together, so that's 26 over 3 plus y equals 9. Now how do I solve for y? Well, I mean, if you use a calculator, it becomes very trivial. But if you use fractions, you're going to have to do some conversions here. So I write it up here. It's in the top 26 over 3 plus y. You need to kind of convert the 9 into a fraction with the same denominator. So 3 will be on the bottom, which means I have to multiply the 9 by 3, which gives me 27. So 27 over 3 is the same thing as saying 9. But now I have a common denominator here. Okay. Now I have to isolate y. So if I keep y on the left side, I'd have 27 over 3 on the right side. Subtract both sides of the equation by 26 over 3, so minus 26 over 3. And so there I now have y isolated, and I have my two fractions I can subtract because they have the same denominator. And so when I subtract the numerators, 27 minus 26 is 1 over 3. So y equals 1 over 3. And there's your y value. And so your point of intersection, therefore, point of intersection, or your solution, is x comes first, so 13 over 6, and then y, which is 1 over 3. And there you go. And it's perfectly fine, and actually it is correct to have the exact fractions listed there. Don't convert them to a decimal, because 1 over 3 is a repeating decimal. You don't want the repeating decimals. You want to give me the exact value, which is all captured within the fraction here. Okay, and so that's my example for this lesson.